Welcome to the No Plan B podcast. I'm Jean Fallacara, and we're here to discuss business, science, and mindset. My guests here are not to sell anything. They are here to open their book of life. We want to understand what their purpose, goal, value, and priority are. I want to look at their action, their behavior over time, and consider what kind of background and experiences they're coming from to be the man and woman they are today. No BS, no cat. This is the No Plan B podcast. Welcome. So I'm super pleased to have Christian Drapeau. I can say Christian Drapeau, as I said in my introduction before, because Christian speaks French as I do, probably better. And today I'm thrilled, digging into for years and years, and I think it's probably the future of everything, stem cell. And Christian actually knows how to crack the code of the stem cell. He wrote a book, Cracking the Stem Cell Code, a fantastic book, actually. I was fascinated by all the research you've been through and all the process where you started and to get to that point. But Christian, no one can do a better introduction than yourself. So why don't you start with that, please?
How I started all the work that I did. My background is neurophysiology. So I was studying brain research at the Montreal Neurological Institute. I was doing research on memory and epilepsy. Interestingly, the phenomenon of epilepsy and at the cellular level is very similar to the phenomenon of memory. And as I'm moving in that direction, at some point I was hired by a company in Oregon that was selling a product that was fairly popular in the 1990s, which was blue-green algae from Klamath Lake. This was just after the passage of the DSHEA, the Dietary Supplement Health and Education Act, and companies making claims about products needed to have science to back up these claims. So I was hired essentially to study the effect of this plant because one of its main benefit was an increase in mental clarity. So we very rapidly identified the active compounds, but along the way, I observed benefits on overall health that led me to sort of an investigative process that led me to basically stem cell research. So since 2001, then my field has completely changed and went into the direction of stem cell research, which is basically what I'm doing today.
Yeah, fantastic. And actually, you cannot change the mindset of a scientist. That's the thing. Like, you've been curious at the beginning, then the curiosity pushed you to go further because you were on something that was like tremendously changing the world. And if we talk about 20 years ago, the stem cell were just like something magical that everyone was looking at. We were kind of convinced that stem cell were only in the bone tissues at that time and was not much we could do. Then we've seen the blood cord collection and all these things, and the stem cell became more and more a pole of attraction, but a pole of many contradiction and polemics as well, because people are against the use of stem cell, the injection of stem cell. You're not talking about injection of stem cell, but I think that before we start, and I don't want to lose our audience, but they're very normally aware about science. Why don't we start by trying to explain what is a stem cell?
Okay. Let's start about describing what is a stem cells, but you brought something that is very interesting, Jean, and I don't oftentimes have the chance to talk about this. It might be a good place to talk about. You say confusions, you say people not agreeing with stem cells or being sort of against it. And it comes from a whole lot of misinformation that was willfully put out there on the marketplace that has confused the heck out of people. It might be good to go through this a little bit.
I like that.
Essentially, a stem cell the best way to define a stem cells, I think, is to first define what is not a stem cell. All the cells of your body are somatic cells. They are cells that will do one specific thing. They will never, to a large extent, multiply and will never transform into a cell of another tissue. If you have, let's say, an injury on your skin, you have a cut, you won't have a cell of your muscle below the CG. There's a cut above, so let's migrate there and become a cell of the skin. It doesn't happen. A somatic cell is one thing. It has one specific function. At the other end of the spectrum, you have stem cells. They are nothing. As a function, they don't really do anything in the body. Their function is actually in their ability to transform into a somatic cell. Historically, they were always be known or believed to be precursors to blood cells. And that's all that they were doing. Stem cells from the bone marrow.
That's cool. Yeah.
Exactly. That's what we all learned at school. And to a large extent, until very recently, and maybe still today in med school, the whole concept that stem cells can become not only other types of cells, but it is their function and it is their role in the body that is not yet very well understood or accepted. But they were precursors to blood cells, and that is the big discovery that was made in the early 2000s. It's the observation that stem cells from the bone marrow were able to become cells of other tissues, and that came with the development of markers like green fluorescent protein, because the phenomenon is invisible. A stem cell gets into a tissue within hours. That stem cells will become cells of that tissue. Under a microscope, it's impossible to tell that tissue cells was a stem cell the day before. And if you look at a cell that looks like a stem cell under the microscope, it will be a lymphocyte. You cannot tell that, you cannot visualize or see the role of stem cells in the body until you mark a cell. You make it green, that stem cells becomes a muscle cell. The muscle cell is green. Now that's it. So that means that muscle cell was a stem cell. That's really what revealed the whole phenomenon. And then from there it exploded.
That's very interesting, because so we can transpose that very simply in saying like stem cells are some sort of a bank of cells that are like with no function, no differentiation. But when they are needed in the body, they're going to move to the place they are needed and just replace the cells that are damaged or dead or whatever. What about let's jump about the polemics about stem cell, because there's so much about the stem cell in the last, I would say, 10 years. It became more and more critical because some people on the line of what you just said, cells with no differentiation migrating to a certain place and transforming into cells to replace others. Some people put that on communication and publication. They said like, yeah, stem cell can turn into tumors. So we have to be careful with that. And then it was part of the starting point of these polemics on stem cells.
Yeah, lots of confusion. At first, 1998, the first time that somebody could, in the lab, grow human embryonic stem cells. It was done before with animals. You may remember the sheep dolly. Yeah. It was done with dogs. It was done with mice, but it had never been done with humans. Someone was able to, Thompson, I believe, was able to, for the first time, grow embryonic stem cells in the lab. So it kind of rekindled the whole hope here that we would be able to take a cell, a human cell, and be able to develop a new heart, a new lung, a new liver, new tissues. Very, very quickly, it faced two main obstacles. One obstacle was that these stem cells, not adult stem cells, embryonic stem cells, can lead to tumor formation. It is still the obstacle today as to why they're not used, and you don't have today injection with embryonic stem cells. They're wild, and they can lead to tumor formation. The other big obstacle was that using an embryo to extract embryonic stem cells was believed by some to be the killing of a human embryo, which honestly, I have absolutely zero position in this whole debate, but we need to just look at it in a very objective way. It is essentially a religious question. Christians believe that ensoulment takes place at conception, but Muslim, Jews, Hindus, Buddhists believe that ensoulment takes place after the 3rd month gestation or later. So that means it's not a true human being until that point. And that is really the crux of the matter. When do you believe that this is a human being? And where the layers to this is that the Pope, John Paul II, said in the early phase of these research, you cannot use a life to help another life. So the bishops at the time, not understanding the distinction between embryonic and adult stem cells, made a blanket statement, stem cells should not be utilized. But that statement really only applied to embryonic stem cells. So it created a lot of pressure out there to push for stem cells, while at the same time, politically, the Bush administration had used this polemic, if you want, this controversy, basically rile up the field, their followers, into making statements like, we're against it because it's baby parts. It has never, ever been baby parts. This is complete fabrication. It has never been. And to me, somewhere the biggest controversy is that embryonic stem cells really come from fertilized human embryos. Where do you find these? They're not fertilized in the lab. They're fertilized in vitro fertilization clinics. So a couple takes a sperm, eggs, makes human embryos, grow them to a certain extent, then freeze them, and then implant them into the uterus when a couple wants a family. When that couple has had the children that they wanted, then they stop paying for the preservation of these embryos. So they're thrown into the sink. They're thrown in the trash.
Right.
These human embryos have been destroyed for as long as there has been in vitro fertilization. And now a scientist comes and say, instead of killing them through throwing them in the trash, we're going through extracting the embryonic stem cells and do research. So, and that's what was kind of jumped on more to create, I believe, some sort of a momentum to bring everybody into the political fold more than really addressing the question, because addressing the question for what it was would have been to say that all the in vitro babies that exist today that are adults are immoral. You cannot have this argument. All of this is in the past. In 2011, the Catholic Church, came forward and organized a huge stem cell conference. I was there at the Vatican, basically to say, yes, we're against embryonic stem cells, but we are for adult stem cells. And it really opened in the press and everywhere the reality that adult stem cells are safe and they can be utilized without any problem. Of course, not everybody knows all this history, so there's still confusion remaining, but this is where we are today.
Yeah, that's interesting, because no one at that time was saying like throwing the embryo or like a product that you were creating before insemination was killing lives as well until then. So this is, well, our society is like that, you know. I think that it's always based on beliefs and stuff like that. I do remember listening to people saying like, you're using the blood of a baby. It's just like, okay, come on. But the concept of your research and your product are actually a totally different way, because you're not using external stem cell. You are preaching that, and I do love that, because the natural way and the natural path of what you state is actually correct. Instead of injecting stem cell to people, so adding something coming from the exterior, you tell people, listen, you have stem cell in your body. Why don't you use them in the optimal way? And to use them in the optimal way, you need to stimulate the growth, the multiplication, the differentiation, whatsoever. How did you come up to that principle?
Well, if I put your question into a general context, when suddenly, I say suddenly, when in a matter of maybe a year or two, lots of documentation appeared in the scientific literature describing how stem cells from the bone marrow could indeed become cells of the liver, of the heart, of the brain. When all of this came out, what really compelled me was that, because the first motivation or the first direction in which scientists went was, okay, what is the best source? So let's go and collect them from the blood, from the bone marrow, from fat tissue, umbilical cord, dental pulp stem cells, hair follicle stem cells, skin stem cells. Many types of stem cells started to be utilized for various applications. And then can you tweak them in the lab or not, and then inject them in the body? Because the obvious conclusion is that if they were enough like this in the body, then they would do their job. And obviously, if we extract them and put them back in and we get results, that means you need to go through a process. And that's what led to the development of banking of umbilical cord stem cells. All the development with tons of patents and IPs and everything, what we have today. But in the background, what was kind of not looked at is that these stem cells that you extract from the bone marrow, well, they are there to begin with. They are in your bone marrow. They are in your fat tissue. They are in your blood. They are everywhere. What are they doing in your body? They're not better because you take them out and put them back in. So what we do with an injection or any of these treatments is that we increase the number of stem cells in circulation through an injection. And my path has been in this process of discovery. So let's go back to where I was before. I'm studying this plant, this blue-green algae. We are trying to understand how it is bringing such a broad variety of health benefits touching in some individual the heart, in other people the lung, the liver, the pancreas, the lung, the skin. And we had no mechanism of action. So when all that science is coming up, and I come across the first papers in 2001 showing that stem cells could become cells of the heart, the brain, and the liver, at that time, I'm thinking, if stem cells can become heart, liver, and brain, they have to be able to also become lung, pancreas, skin, and the rest. It's not thinkable that stem cells could become those three tissues and not the rest. Yeah, it's just a matter of time.
Yeah.
So let's watch the scientific literature. We will see that they can become everything. And if, let's assume, okay, we'll go back now in 2001. Let's assume that yes, they can become everything. They cannot become all these cells and it's not their function. How can a stem cell become a brain cell and it's just like a bizarre stem cell? No, it has to be its function. So if they can become cells of other tissues, they have to be the repair system. So if they are the repair system, what if I have a plant that stimulates the release of stem cells from the bone marrow? They will go into the pancreas of the diabetic, the heart of the heart patient, the lung of the emphysema patient. So you should expect a broad variety of health benefits, and that's what we had. So that was really the starting point. This hypothesis at the time, I can tell you, very, very far-fetched, insane hypotheses. I don't know how many times I was called an idiot because at the time it was completely, I mean, it was completely against many different dogmas of the time. You don't release stem cells. They're not becoming cells of other tissues. They're now putting more stem cells in circulation. That doesn't mean anything for your health. In any case, all of this was developed and documented later on, but that was the starting point. What if that blue-green algae act as a stem cell mobilizers? So we developed a lab where we could count stem cells, and that's what we started to do. We started to count stem cells before and after taking this blue-green algae, and we very quickly documented that it increased the number of stem cells in circulation. So that was my starting point into this field of stem cell research.
And the starting point of your company as well. But as a researcher, why you didn't go the normal way and trying to stimulate the growth of stem cell using, I don't know, radiation or other factors that you can use? There's many factors that you can use in biochemistry today to stimulate that. Why you went on the plant aspect?
I mean, because my interest in stem cells did not come from an interest in stem cells. It came from a quest to explain what was the mechanism of action behind that plant, which was blue-green algae from Klamath Lake. So as I'm researching that plant and I discover that plant acts as a stem cell mobilizer, then it puts me in the field of stem cell research, but really with that plant. And then from there, the next thought process was, well, we evolved in symbiosis with the environment. If stem cells are the repair system, and we can go into the detail of what that means, I literally believe, it's more than a belief, I know that we have identified a novel system in the human body. It will take some time, I think, for academia to recognize it as such, but we literally have discovered the body as a repair system. So if we agree that we have a repair system and we have evolved in symbiosis with the environment, it cannot be that there's only one plant that supports the stem cells in the body. So how do you find the others? So we started to look at other plants because we were in that direction now, plants and their effect on stem cells. What other plants has been known historically, globally, to be associated with a broad variety of health benefits? Goji berry for longevity, medicinal mushroom, fucoidan coming from seaweed. You can come up with a lot. Astragalus, we have not tested it yet, but ashwagandha, for example, a lot of these so-called, how do you call them? I forgot the name. Adaptogens. These so-called, what is the definition of an adaptogen? Let's be honest, okay? It's something that touches many aspects of human health and we don't know how. We don't have a clear mechanism of action. We put all of them, we call them adaptogens. We have since come with various, mechanism of action, but I started to look at many of them and tested their effect on stem cells. They almost all have, all of those that we have tested so far have an effect on stem cells. So that was the first round of research. Then the next question to me was, outside of this global market, what are they doing in Madagascar? They don't have access to goji berry in Madagascar. I mean, but not to a large scale. They're using what they have locally. So what are they using in Madagascar, in Papua New Guinea, on the Tibetan Plateau, in South America, in Africa? What are they using in these local communities for helping a broad variety of health benefits? So we discovered sea buckthorn berry from the Tibetan Plateau, Aloe macroclada from Madagascar. And all of these, how we discovered them, how we developed relationship with locals to be able to actually harvest these ingredients, turn them into an ingredient. Every single one of them is a story on its own, a fabulous story on its own. And these are the various ingredients that we have discovered so far, and they are the key ingredients in stem StemRegen.
So you put them in a blend. So you went from a broad perspective of trying to localize and figure out where those plants mainly were and were growing, how these ancient civilizations were using them. No counter effect in between each other, no decrease effect because you're using one and the other. So the process of saying like, okay, this is the perfect blend for stimulating stem cell with this quantity, this number of grams of each of them, you might have been going through some sort of like bump into your research. Like, for example, I put ashwagandha or another one together. The effect is like, is not going the right direction.
Yes, we have played with some of these. So I have had other versions of StemRegen before where the blend did not necessarily give what we would have expected. But the main thought process behind the blend that we have today is try to combine herbal extracts that have different mechanism of action for the same outcome, which is stem cell release. There are three main mechanisms of action to release stem cells from the bone marrow. So as we go through these plants and we identify different mechanism of action, that's how they were blended. And that's really what we have right now. These plants, they all have a different magnitude of release. They're using different mechanism of action. And some of them were also discovered with, for an example, notogensin. Notogensin was added to the formula after working with a doctor that I've been working it now for almost like 12 years. And as we developed the first version of StemRegen that did not have at the time notogensin, this doctor has used something like 35,000 bottles of StemRegen since 2016. So he has an amazing perspective of the effect that the product has on his clients and his patients. But at some point he shared with me, maybe that was like something like in 2018, he shared with me, Christian, when I put patients of mine on ginseng while they are also on StemRegen, they all seem to come back with better results. So I started to dig in the scientific literature. So this is not work that we have done, but as I dig in the scientific literature, I come out with a number of articles documenting how notogensin, which is the original Chinese ginseng, so the one that takes about 7 years to grow after harvest, it leaves your soil depleted. You need to wait 3 to 5 years for your soil to be fertile. So that ginseng had been documented to release stem cells from the bone marrow, not only to release stem cells, but to release stem cells and in one study help reverse conditions like atherosclerosis. In another study, it actually provided mechanisms of action of how that plant was working. So as I found all that information, then we added an extract of notogensin to StemRegen. So this is sort of the story of all of these were developed because of the observation of a synergy between these ingredients or a planned or expected synergy due to their mechanism of action. And now what we have with the StemRegen that we have today is with all the doctors that I've worked over the years is absolutely without question the strongest or most potent formulations that I've developed over the years.
The StemRegen is for me like the transposition of some sort of software for the body where you have version 01, version 02, and it's probably an ongoing process that will keep going in the same direction for the rest of your life and the following lives that are going to be over 150 years, of course. And because we make discoveries every day on new adaptogenes in general, one that is very, very known, resveratrol. You're a French speaker. You drink wine. It's one of the stem cell generator. We're talking about curcumin as well today. All these ingredients are complementary to what you do. And there's a lot of research ongoing on those products. More recently, we see David Sinclair talking about a few molecules, one behind the others to reverse aging. Everything comes back to me. One question, you know, this, trying to remember I think it's the A-flick limit, 1960, I think so. Yeah. Where the number of cells are like supposed to divide not over 50 or 70 times. That's the maximum you can do. How this could impact the use of the product or to overstimulate our stem cells and things like that. What's your perspective on that? I mean, it's always the point, like for me, I love biohacking. I love optimizing what we do. And we're trying to have a better skin, better eyes, better this, better hair, better muscle. But at the end of the day, pushing our body to a certain limit, like even intermittent fasting is a growth factor for stem cell. So pushing our body to those limits, extremes, are we putting our body at risk in a way to reach the senescence of the cell we have faster than others? I'd like to hear you on that, to have your feedback on that.
Okay. Aflic limit is a phenomenon that is seen in tissue cells. You have a stem cell in the bone marrow. That stem cell in the bone marrow as a stem cell as telomerase. That stem cell will multiply during the entire life of an individual. Contrary to everywhere else in nature, cells divide everywhere else in nature through what is called symmetrical cellular division. So one mother cell divides into two daughter cells. These two daughter cells would have one of the filament of the original DNA and then a copy. So they are identical. In the bone marrow, what you have is asymmetrical cellular division. So the original DNA goes into one of the daughter cells, whereas the copies go into the other daughter cells. That's the one that will be released in the blood circulation. And the original DNA is maintained in the bone marrow. So the bone marrow has a very, very strong homeostasis, meaning when you release 10 million, you're not lacking 10 million stem cells in your bone marrow. Right. It just maintains itself very well. And it maintains itself, these cells, as telomerase. So they have not been affected by that cellular division, and they retain the original DNA. It is a phenomenon developed. When you think about it, it's just like such a beautiful process that nature has developed, so that as your cellular stem cells divide, then you don't end up with a copy of a copy of a copy, which very quickly will lead to massive types of mutations. We would not be able to survive as a species, if we did not have asymmetrical cellular division. So what you're referring to is that when a cell leaves the bone marrow and gets into a tissue, that is no longer the original stem cells in the bone marrow. It will become a tissue-committed stem cell at first, which is a progenitor stem cell. That stem cells could still, to an extent, reverse back to a more primitive state to go into another tissue. It could, but to a large extent, its destiny now, it's to be in that tissue. It will start to multiply no longer than 50 to 70 generations. That's your Aflic limit. So now that stem cell, and that Aflic limit is to a large extent conceived as being a process to prevent tumor formation. You don't want these cells to age and have the capacity, as they are aging and becoming dysfunctional, to now start to divide erratically. And that is the Aflic limit. So that is addressing tissues, not the bone marrow, which leads to another concept, which is sort of the flip side of your question, which is stem cell exhaustion or stem cell depletion. That is a phenomenon, not of the bone marrow. Nobody dies because one has reached the limit of its bone marrow and suddenly you're walking on the street and that's it. You fall dead because you used your last stem cells. It doesn't happen. In the bone marrow, yes, there's a shrinkage of your red marrow that happens, but that red marrow that is left still continues to release stem cells. The depletion is a phenomenon of the tissue, which you see more acutely in tissues that have a rapid turnover, like, for example, your gut. When you have a condition like irritable bowel syndrome, inflammatory bowel disease, or Crohn's disease, or colitis, any of those, you have an insult to the tissue that requires that the tissue tries to repair itself at such a pace that it runs out of it depletes its own stem cells. This is stem cell exhaustion in the tissue. That's when you experience the acute phase of the problem. So you need to replenish the tissue in order to have the tissue be able to repair. And you do that by putting more stem cells in circulation. Stem cells can then replenish the tissue. So stem cell exhaustion is a phenomenon of tissues. You can deplete stem cells in your tissues, and that is what really is the aging of that tissue. That tissue now is no longer capable of replacing the normal cellular loss that is taking place with aging. That is when your tissues start to develop dysfunction. The way to prevent that, put more stem cells in circulation. They will migrate in tissue, replenish tissue-committed stem cells, and will reconstitute the stem cell layer of that tissue. So it all comes back to tissues, to stem cells from the bone marrow that you support. So stem cells from the bone marrow that you support their release into the bloodstream, which is what StemRegen does.
That makes it very, very clear. So in a way, your product is some sort of in French, they call it la fontaine de jouvence. The translation means like the fountains of rejuvenation, like the fountains of life, the Graal, the holy Graal of being almost immortal. Do you think that if we were able to stimulate the stem cell appropriately, we could actually stop getting older?
When this whole concept dawned on me, so in 2001, and I'm just thinking, wow, stem cells are the repair system of the body. If we can put more stem cells in circulation, you support this natural ability to repair. And now we have plants that can do that. I was under naive phase of thinking, that's it. We are putting an end to disease. Yeah. And obviously then I got a reality check from normal life. The market was not ready to accept that. Still today, 20 years later, still trying to bring this message that, yeah, your stem cells are, like you call them, your fountain of rejuvenation, your fountain of youth. Yes, I do believe that, let's not call it immortality. Let's for now just say during your lifespan, we can really optimize health span. And the understanding here comes from the fact, and this understanding came later as I was developing, all this research. It's to understand that we lose cells every day. We understand in the world of medicine, generally speaking, we may not express it that way, but the general understanding is that we grow, we mature, we reach maybe 25 years of age. Remember what you could do athletically at 20. You were, but you were invincible. You were Superman.
No.
You're better now. So, but we are at 25, the peak, and then slowly things start to happen associated with aging. And so we experience it in our lives as a slow decline. But physiologically, it's not happening that way. What is happening is that your red marrow converts into yellow marrow that does not make stem cells. So by age 30, you have lost almost 95% of your red marrow. So it corresponds to a drastic decrease in how many stem cells are in your bloodstream available to repair or offset cellular loss. And what is really happening is that you lose cells every day. It is not a slow decline over time. No. You have a new liver every 2-3 years, half of a new heart every 25 years. Every single organs and tissues of your body are constantly in a process of turnover. As long as you have enough stem cells in circulation to offset cellular loss, you have a balance. You're fine. You don't experience in your life the decline. It's the moment that you stop having enough stem cells to offset cellular loss that now you start to slowly accumulate daily unrepaired damages that will over time add up to what will be your experience of aging. So I do believe that by putting more stem cells in circulation, giving back the body its innate ability to repair and to stay healthy by replacing the cells that are being lost, we optimize with the body's own repair system, we optimize our ability to age with health and not develop all the so-called age-related disease. Yeah. I proposed this in an article in 2013. It was an editorial, I think it was in the Journal of Stem Cell Research and Therapy. And this whole concept had emerged from a lot of observations from cases that we had with those plants that we were developing and some data from the scientific literature. So in that paper, I said, there's one way to observe, to document if this concept is true. Go count the number of stem cells in the bloodstream of people who have developed any one of those age-related diseases and compare that with people who are healthy of the same age. Now there's probably about 50 of these articles that I know of. And if you count the number of stem cells in people who have diabetes, various forms of diabetes, and at various stages in the development of diabetes, atherosclerosis, hypertension, erectile dysfunction, liver failure, kidney failure, lung disease, COPD, Parkinson, Alzheimer's, arthritis, all of them. And it continues, heart disease. All of the people with these problems have, on average, less than half the number of stem cells that you find in healthy people. So my task right now, through a review of the scientific literature, it's my next book, is through a review of the scientific literature, I believe that we could, it's vast meta-analysis, but I think we can reach an understanding that there is a level of stem cells under which we now at risk of not fully maintaining our tissues and developing one of these age-related problems. And you just then have to go through an analysis of your life, of your genetics, your family history, your lifestyle, your exposure to environmental toxins, your past epigenetics, and you can have an idea of what is your weakness in your physiology. And now you can tell that this decline in stem cells, this deficiency in stem cells will express itself for you in one specific area of health. And you can start to prepare for this by supporting that organ or that system, but definitely by putting more stem cells in circulation to up your ability to repair, because what you will experience in 20 years has started today, microscopically, and it will be the sum of all the daily unrepaired damages that you don't experience because they're too small, but they end up being the problem.
Yeah, true. So true. But humans are weak. So the extreme of this beautiful statement that you're making, where we can optimize our lives and our body and using, of course, DNA is the best tool for that, and environment and lifestyle. Some people will probably use it in the wrong direction, trying to, exceed some performances in sports so some regulation will be coming around that, and they're probably going to be, I just thinking out loud, and they're going to be probably the same problem we had with the Pope at that time, stopping or slowing down the research because of regulation. Our society is always putting regulation over regulation over regulation until we understand that we could go through. Do you see a negative effect or potential of using your product, for example, to get into higher performances in sport and beat all the world records and make more money if you are record holder, for example?
Yeah. Well, as a society, I think that we can all agree that we're not immune to stupid regulations or regulations that really nonsense. So could it happen? I mean, I don't know, but it would not be, I don't know how to say it. It's a natural part of your system. It's like being a runner, let's say, and go and train at high altitude. Is that illegal? Because now you've supported an aspect of your body to basically get better. So all that we do is that we use plants that have absolutely no performance enhancing compounds in any shape or form. We're just supporting your innate ability to repair, which quite frankly, people have done forever. People consume sea buckthorn berry. People consume blue-green algae. All we do is that we suddenly discover that they are having an effect in the body that we had never looked at before. That's really all that we're discovering. So could you take that and say that it's performance enhancement? It is not performance enhancement. But where it does enhance performance is in the fact that, and we have seen that with many athletes, when you go to the gym or you go to do like a super intense workout, you create micro lesions every single time. When you create micro lesions, you have a protective aspects of your nervous system. It's a very well-known loop in your spinal cord that is going to prevent the full contraction of a muscle that has micro lesion, because you don't want to re-injure that muscle. Of course, you can take painkillers, you can overcome that limitation, but it is there. When you go back to your next training, let's say 2 days, the day after or 2 days later, you cannot train to the fullest. Your body will inhibit your ability to train. But if you can now accelerate the process of recovery of all these micro injuries, when you go back for another workout 2 days later, you can now, with the same effort, you can gain so much more, because now you can train to the fullest. So as you accumulate the added benefits at each of these workouts, it does lead to greater performance out of that same training. And that's my best way to understand why many athletes who have taken Stem Regen have come and shared that oftentimes, let's say 5 years later, they suddenly beat their own record. Whether it's running, lifting, whatever it is, they beat their own record. Some of them have beat the world record years after they have established their own personal record. And the only explanation that I can have, because it is not performance enhancement, it's just that you just gain more out of the same training that you do.
Yeah, you have better recovery. Like 10 years ago, recovery was not even a question in sport. Like people were not paying attention. Today's you have to pay attention as much as you train. You have to pay attention to recovery. So the supplement you make are available on capsule, bottles, not liquid.
Not liquid yet, no. I mean, we could eventually, but right now, it's in capsules.
No, I think that today people are used to take supplement in capsules. I was just curious. Do you have to take them regularly, like every day, before a meal, during a meal, empty stomach, not empty stomach, with drinks? Is there any counter effects or counter indication, like can you drink alcohol if you take these?
The studies that we did were in the morning on a light stomach. And the reason why we did light stomach and not empty stomach is that stress, not necessarily mental stress, but physiological stress can affect stem cells.
Yeah.
So if you start to be hungry and you don't eat, you will enter into a level of physiological stress. So we wanted people to not go through that level of stress as much as possible while being on an empty stomach. So it's like a few crackers in the morning and then a few crackers, during the time of testing. So you can call it almost like an empty stomach. And that's the data that we have. Now, after 20 years of doing this work, I can tell you that all the stories that we've heard with results that are mind-blowing. I mean, we have quadriplegics getting mobility. We have amazing cases. Yeah. They did not take it on an empty stomach. They took it in all kinds of ways. So I have no information today that is telling me that there's a better way than another to take the product. Sometimes people say, yeah, but you repair at night. Wouldn't it be better to take it at night?
True.
Yes, you repair at night, but when you release stem cells, they will circulate in your bloodstream up to about 6 hours. They migrate in the tissue. They will multiply for the next few days. The whole cycle of tissue repair is beyond one day. So I don't think that there's a better day. At least I have no data right now telling me that there's a better day or better time than another to take the product. So, now, we know that alcohol reduces the ability of stem cells to migrate into tissues. Same thing with cigarette smoking. Same thing with stress, anxiety. When you have cortisol in your blood, you shut down the ability of stem cells to do their work. So there's a lot of things that you can do to suppress the ability of stem cells to do what they're doing. So you definitely can stop smoking. You can try not drinking while you take the product, definitely. But stress, it's just a matter of learning to manage stress. You can do. But to me, it's a fascinating observation, because if stress suppresses the role of stem cells in the body, and they are your repair system, and we see such a link between stem cells and the development of so many different types of age-related diseases that have all been also associated with anxiety. I find it very interesting. Have we discovered the culprit of it, which is stress really leads to the development of these various types of problems, because stress shuts down your ability to naturally repair. It's probably not the only thing, but it's definitely probably one of the root cause of the issue.
Yeah, it's a major factor, and we're discovering it more and more every day. We see that the stress and anxiety are actually really the precursor of not just aging, but of all sorts of sickness and illness, especially in the brain, and that's your specialty.
Correct.
One question that probably most biohackers will ask you about the product, because they would be very interested in having it, is, I do intermittent fasting. Can I take them, and does it break my fast?
I do not believe that it breaks your fast, because it's a very poor dietary supplement in terms of macronutrients, calories, sugars, proteins, everything that is macronutrient. You're really putting a bunch of bioactives into your digestive tract. So I would not expect that to really have an effect on intermittent fasting. But I'm not an expert in that domain, so maybe we should ask some people who are expert in that domain. We did look at this once, and it was in the order of something like, less than 10 calories. And it's coming from some of the fibers that are inadvertently into the product. You have an extract from a berry, so it's mostly polyphenols, but it's 30% polyphenol. So you have other things. So some of these other things are also polysaccharides to an extent. So some of them have a level of, can be digested. They're not all fibers. So overall, you end up with a few calories, but it's not a lot.
We're getting to those natural and holistic approach now to become better. One question, Jan Mitchell with his product, the C Carbon 60, was in my podcast recently, and he was injured on motorcycle accidents. So instead of going through the whole surgery, he got stem cell injected in knees and tibia, and where he had fractures. Can you replace the protocol of stem cell injection by taking the supplement? Do you think it's possible?
It's a delicate question. We are doing a study right now looking at that specifically, meaning one group with stem regen, one group with stem cell injection, and one group with a combination of both with congestive heart failure. So the study was started just before COVID. So COVID sort of stopped it. We are resuming it right now, but we already had one arm of the study, or at least a part of the study of people taking stem regen, and people with more than 2 to 3 years of stable congestive heart failure, chronic stable congestive heart failure, after 6 months of taking stem regen had pretty much reversed to a normal condition. So we have an average about 19% improvement in ejection fraction. Wow. So we continue with the study to be able to compare, but the motivation to do that study is that the cardiologist with whom we do the study, Dr. Garber, he has been a colleague for many years, and consistently always use the two together, injection with stem regen, because he tells that he gets much better results when he's doing this. His colleagues are asking him what he does because they see that he gets better results. So I believe that that's really the optimum. Yeah, side by side. And I'm making this comparison here, not out of studies. So just out of, let's say, thinking process. If you go to a joint or an area that where stem cells have very difficult access, then probably an injection within the joint will be superior. When we talk about injection of stem cells just systemically, we'll inject about, let's say, a big injection, 150 million stem cells, which may cost $20,000, $25,000. You have about 12 million stem cells in circulation right now in your bloodstream. You basically 10x the number of stem cells in circulation. This overwhelm massively the ability of stem cells to migrate into tissues. Stem cells migrate only in the post-capillary venule, millimeters in your whole vasculature. So you overwhelm that area. So many of them are actually recaptured by the bone marrow. Now you have about that amount, 150 million stem cells in your bone marrow. So you now double the number of stem cells in your bone marrow. So you overwhelm now your bone marrow in feeding and maintaining these stem cells. And that is why the estimation is that the effect is what it is, but it comes with about an estimated survival of 10 to 15% of the number of stem cells that have been injected. It's worth it because it gives you the result that you have. So I believe that is why stem regen brings such a better result, is that now these stem cells that are stressed in your bone marrow, you re-release them and you give them another round in the body, another opportunity to go and migrate in tissues. So you keep them alive for longer in providing more opportunity for repair. I think that it's coming from that synergy. But if we compare it with the release, stem regen will put in your circulation 5 to 10 million additional stem cells. It's much less than an injection, but it's physiological. You do not overwhelm your system by another 5 to 10 million. This is well within the number of stem cells that your body would release when you have an injury. And if you do this every day, after a month, you have released, let's say, 150 to 300 million of your own stem cells. And you can continue to do this for long periods of time. So we have not compared the two. I cannot tell you one can replace the other one. I don't want to go to that extent. What people doing injections are doing is a great contribution. It has helped a lot of people. But I cannot stop thinking that stem regen is an amazing alternative to people who cannot travel for a treatment, cannot afford a treatment. It does put into your body a number of stem cells. It's natural. The product doesn't do anything other than supporting the body's innate ability to repair. And as you do this every day, it can amount to very, very significant benefits. So I go back to your question that you had before. Do we have to do this every day? It really depends on many factors. I have done this every day for 20 years because in my mind, my understanding right now is that you accumulate your small deficit daily. You can, if you offset those deficits daily, it's probably the best way to counter the accumulation of these deficits over time. But it could very well be that, let's say, 3 times a year for a month, just take the product, flood your tissues with stem cells, and you reach repair. Maybe you don't have to do this every day. It's something that might be interesting to investigate as we move forward. My concept has been do it intensely when you need to repair something, so you really boost your ability to repair. And after that, do this every day for maintenance. So that's the concept under which I have done this for the past 20 years. But maybe it's possible, to do this more in some sort of a cure.
No, I think that we're true on that. Everything that you implement in your life, step by step and slowly and steady, has always a better result. It's been proven on many aspects of our lives and even performances or whatsoever. So this is totally agree with that approach. I have one very naive question. If you have more stem cell circulating in your bloodstream or in your bank, do you need more supplement to sustain their viability in the run?
It's a very interesting question, because I think that when we have really fully understood it's more than crucial, absolutely vital part of our biology, which is the fact that as you release stem cells and they migrate in a tissue, and that stem cell will now become, as it extends its aphelic limit, it will have become several thousand cells, if not hundreds of thousands of cells in that tissue. Actually, if you go to the full extent of 50 generation without any hindrance, and you do that, you're talking about billions of cells.
Yeah.
When you get that magnification, all these cells require vitamins, minerals, support,
Energy,
macronutrient, energy. So yes, I think that so today we say the brain uses like 20% of your energy. I believe that when we have fully understood what this repair process is doing in our body, probably equally, more or less, at least in the same magnitude, we will realize that this day-to-day repair process consumes a very significant proportion of our nutritional need in both macronutrients, calories, but also in building blocks, but also in micronutrients, vitamin, minerals, nutraceuticals, and the rest.
Yeah, I expect that to be true, actually. And I expect also people to then think about using both sides, using the product and losing weight, the dilemma for society, because if you need more nutrients to sustain your viability, then you're going to go like, oh, I'm going to go on depletion and lose some weight. Anyway, it's our human behavior. Hey, Christian, I'm just like bluffed. I could hold you here for another 2 or 3 hours. I know that you have another meeting coming up.
We can continue as long as you can, or we can do another one later.
I'd like to have you on the number 2 because you generated a lot of question, not stem cell, but question today. And I'm going to have you back because there's many aspects I want to cover with you. It was fascinating. This product seems to be unique in a way that it's natural. I love it. And it's just like getting our bodies better, simply, as simple as that. Mm-hmm. And no injection, no radiation, no other things. If you add sleep, exercise, some fasting once in a while, and no stress, we're good for 200 years.
There you go. But that's what it is. If I summarize all of that in a few words, it's to understand that just like you have systems, like let's take an example, the immune system. It's your lymphoid tissue that are releasing one specific type of cell, your immune cells. They will circulate everywhere in the body, but they will go where? Exactly where you have an infection. They will, through a very well coordinated process, go and migrate beside pathogen and will release compounds or do something to kill that pathogen. It's a very well coordinated system, vital system. It's our immune system. Mm-hmm. Now we discovered a tissue, the bone marrow, that releases a specific cell, the CD34 or stem cells, that is going to go with a very coordinated process to a tissue that needs repair. Stem cells will go in that tissue and will transform into cells of that tissue, literally repairing that tissue to keep you alive. It is literally your repair system. Once we understand that the body has a health system, that's what is keeping you healthy. All over the years, you remember 20 years ago, we're talking about the immune, and before, the immune system goes and repair. No, the immune system does not repair. It does not repair. The immune system kills bacteria. It's stem cells that repair. So now we discover we have a repair system. Your health system is what keeps you healthy. Is there a better way to stay healthy and to leverage your health system? It's when I look at it that way that I'm just thinking, we collectively, the scientific community, with all that data, we have discovered one core aspects of human health that if we start to support it, we will change the face of the earth in terms of wellness.
And even the way of the medicine is done and the therapies are done, because instead of going to the result itself, we're going to go to the root of the problem. So it's beautiful. It's a revolution in science. I hope, I'm convinced you are on the right path there. I just want to remind everybody about this book. It's fascinating. Honestly, I was just like, my goodness, it's so into it. And I'm a fan of everything related to stem cell and genetic in general anyway. But this is beautiful. Where our folks can find your product? We're going to put the website anyway, but you can probably tell people they want to try the product, buy it, or go into it, which I recommend.
So KaliaGen.com, this is KALYAGEN. Kalia means youth, vibrancy, and then gen, regeneration. So KaliaGen.com, and then they can get all the information there and get the product.
Yeah, go to the website. It's lots of information for the skeptical ones. There's a lot of links that you can get on studies, publication, and stuff like that. And you know that for me, science is the first thing to follow. And you're right there. Christian, it was a great pleasure having you. Thank you so much. And promise me, please, to come back. And I'm going to have a list of questions for you.
My pleasure, Jean. Thank you so much.